Alright, you're going to have to record this one again since it didn't work the first time. This is 6.4, properties of definite integrals. We already did indefinite. And we've done definite as well. Now we're just going to learn what properties they are. You'll find they're quite similar to stuff we've learned before. Let's start with a little bit of review then. So for this one here, what I need to do is first of all take the actual integral, which would be x cubed over 3. Of course, that's 3x cubed over 3 minus 5x plus c, where I'm simply adding one to the exponent and dividing. And of course, these are going to go away then. And it's just going to be x cubed minus 5x plus c. And I'm going to evaluate that from 7 to 1. So when I put that together, that's going to be 7 cubed minus 5 times 7 minus 1 cubed minus 5 times 1. And so I get 343 minus 35. 1 minus 5 is negative 4. Minus negative 4 is plus 4. And so that's going to be 308, 312 when we put it all together. Alright, so let's take a look at the actual properties that we have then. So if we are doing the integral from a to a, obviously the area underneath nothing, because from a to a is nothing, is going to be 0. This is literally, if we think of the fundamental theorem of calculus, f of a minus f of a, clearly nothing. Now if we're going from a to b and we have some point c in the middle, kind of like we did with limits as well, we can take the integral from a to c of fx dx and add the integral from c to b of fx dx and get the integral from a to b, where we just stop at some point in the middle. Now here, if b is bigger than a, then we would, or sorry, if b is smaller, then what we should be doing is flipping this. And so then, sorry, oh, there we go. I was like, what am I suddenly looking at the wrong one? There we go. Here. I was like, what are they talking about? B is on the bottom already. Cool. All right, sorry. So if we're going from a to b of fx dx is equal to k, then when we switch those, it simply means that it's going to be negative k. And that's where this one comes in. If b is smaller than a, that's not the way that we usually write them. So we should be flipping it. And so this would be equal to negative the integral from b to a of fx dx, where we're simply switching the order of those there. All right. And then if we have some constant multiplied by it, it doesn't matter. Just like in limits, the constant can be on the inside or outside. So this is the same as the constant times the integral from a to b of fx dx. And again, if we've got two things, we did this in the last lesson, if they're added or subtracted, we can just take them separately and think of it as the integral from a to b of fx dx plus the integral from a to b of gx dx. Sorry, it doesn't have to be plus. It could be plus or minus. All right, let's do a little bit of a review now on what even and odd functions are. So an even function, this is going to mean that the function is reflective, what is that called? Symmetrical over the x-axis or the y-axis here, so that this side and this side are going to be identical. So this would simply be equal to 2 times the integral from 0 to a of fx dx. Or we could do it as 2 times the integral from negative a to 0 of fx dx. Likewise, if it's odd, and this is one of the ones that we did yesterday, if this is negative a and this is a, then it means that this area here is exactly the same as this area. And so just like the one we did yesterday, that means it's going to be 0. All right, so let's try and actually apply a few of these. So if we are doing the integral from 3 to 0 instead of 0 to 3, like it's told us up here, then what we can do is we can say, well, that's the same as negative the integral from 0 to 3 of fx dx. And we know that from 0 to 3 it is 6. So this is just going to be negative 6. Now, if it's going from 0 to 7, just like we said, 3 here would be in between that, and so we can put the two of them together. So this is the same as the integral from 0 to 3 of fx dx plus the integral from 3 to 7 of fx dx. And the integral from 0 to 3 is 6, and the integral from 3 to 7 is negative 8. So if we add those two things together, we get negative 2. All right, and if we're doing the integral from itself, like a point to the same point, it's just 0, because there's nothing that can be under that. This one here, we're going to combine 2. So the 3 should be on the bottom, so the first thing we're going to do is flip that. And the other thing that we can do here is take that 3 and move it outside. So this is negative 3 times the integral from 3 to 7, and that was negative 8. So that gives us 24 in total. All right, so then here, this is the one that's a little bit trickier that students sometimes get messed up on. So the fact that there's a 2 here just means that you're taking a normal integral. They get all hung up on like, oh, but it's f, so like, it's not a big deal, right? What you're going to do here is simply think of this as the integral from 3 to 7 of 2 dx, plus the integral of 3 times the integral, I should say, from 3 to 7 of fx dx. Now, this one we just need to actually do. So it's 2x evaluated from 3 to 7, plus 3 times the integral from 3 to 7 of fx dx, which we know is negative 8. So then we have to work this out, which is 2 times 7 minus 2 times 3, and then minus 24 when we simplify that. So what's it going to be? 14, negative 10, negative 16 in total. All right, and over here we can see that this is an even function, which means that it's going to be the same from 0 to 3 as it is from negative 3 to 0. So we can say it's 2 times the integral from 0 to 3 of fx dx, which is important because we already know that that is 6. So this would simply be 12 in total. And kind of similarly here, if it's an odd function, then this part from negative 3 to 0 has to be equal to the part from 0 to 3, and so this thing's just 0. There's nothing else to it. All right, so let's try applying this to a couple others here where we actually need to do some calculations. We're not just given the answer or given what they're equal to. So here we have a continuous function, and they want to know the value of the integral from 0 to 3. Well, that literally means go from 0 to 3. Now, since we don't have the equation, we need to break this up into 2 shapes. Let's call this shape 1, which is the trapezoid, and shape 2, which is our quarter of a circle. So for the trapezoid, it's going to be a width of 1 times the average of my 2 heights, which are 2 and 3. And so altogether, that's 5 halves. But to that, we need to add a quarter of our circle. Our circle here has a radius of 2, so that's going to be pi times 2 squared. And of course, 2 squared over 4, or 4 over 4 is just 1, so this will be plus pi, and that would be our answer. Now, if we want to go from 0 to 4, remember this is the same as thinking of it as just from 0 to 3 and then 3 to 4. So since we already have this, we know that it's going to be 5 halves plus pi plus the part that is from 3 to 4. Now, I'm going to say it's negative because it's below the x-axis, so it's actually going to be minus whatever this is. And this is just a little triangle where the base and height are 1, so base times height divided by 2, meaning we get 5 halves minus a half, which is 4 halves, which is 2. So we get 2 plus pi. All right, now what about here if we're going from negative 3 to 3? Well, this is an even function. So if it is even, that means it's the same as 2 times the integral from 0 to 3 of fx dx. And we already found that. So it's just going to be 2 times 5 halves plus pi. And I'm getting that from this one here where we did 0 to 3. So then when I distribute that, it's going to be 5 plus 2 pi. All right, so now what we're going to do is we're going to apply some of that fundamental theorem that we learned. So if f of 0 equals 5, what is the value of f of 3, where f is the antiderivative of f of x? So if we have 0 and we need 3, that means that has to be the bounds on our integral. So we're going to go from 0 to 3 of fx dx. And that's going to be equal to, based on the fundamental theorem of calculus, f of 3 minus f of 0. Now, we know what this is already. We found it earlier. It's 5 halves plus pi. F of 3 is the thing we're looking for, and we know f of 0 is 5, which means that we're literally just going to add 5 to both sides. And let's see, that's 10 plus 5, so that's 15 halves plus pi is what f of 3 would be equal to. Now over here, same kind of idea, although this one is a little bit more complicated because this time we have -2 and then we are looking for 2, neither of which we already have. But that's okay. We still know that those are definitely our bounds. Fx dx is going to be equal to f of 2 minus f of -2. Now, f of -2 was given to us, so that's easy. And this one we can find, right? Because that's just going to be, because it's symmetrical, it's going to be 2 times the integral from 0 to 2. So basically almost everything we calculated that first time, except we're not going to include that little triangle there. So that means that this is going to be 2 times, and instead of 5 halves plus pi, it's going to be 5 halves minus a half. Now where I'm getting that from is I know that this triangle here is the same as this one, so there's no sense in me calculating 1 times a half again. So therefore, this is going to be 2 times 2 plus pi. And it's 2 times it because it's an even function, and we're going, so the -2 to 0 is the same as 0 to 2. F of 2 we weren't given. F of -2 we were, and it was -2. So minus -2 is plus 2. So now we're going to subtract that and distribute this at the same time because we're smart. So 4 minus 2 is 2, and then 2 times pi. So 2 plus 2 pi is going to be equal to our f of 2. Excellent. All right, now if we were in class, we'd take a break, but we're not in class. So let's keep going. Okay, f is a continuous function on the closed interval from -3 to 4, where f of 0 is 3. As soon as you see something like that, that's your initial condition. Later on, you guys will give you context as to why or what those initial conditions are, but when we're first learning, we're just going to give them to you so that you can actually work on the problems and figure out the math. Then we'll apply context later. So the graph of f prime is over here, and the derivative of f consists of one line segment and a semicircle as shown. On what intervals is f increasing? So let's go back to stuff we did quite a while ago. Well, let's start with the justification. It's always easier. F is going to be increasing because f prime of x is positive. And that only happens right here from -3 to 2. So -3, -2. All right, now find the x-coordinate for each point of inflection on the graph from -3 to 4. Well, again, let's start with our because. So this happens because f, there's 2 ways to think of it, f double prime of x changes sign, which is great, but we don't have that. So how can we kind of make it work with what we have with f? Well, f double prime changes sign if f of x, so when f prime of x has a relative max or min. And it has 2. It's got this one and this one. Don't forget this one. I know it's like, oh, we can't take the derivative. You're right. But remember, we also modified our definition of critical points to include when it is undefined. So that means this is going to happen. Let's, instead of saying x, let's say our points of inflection. So our poise are at 0 and 2. Well, I guess, you know what, let's write that better. Poise happen when x is equal to 0 and 2. That's a better way to say that for sure. Okay, so now we're going to find the tangent line to the graph at 0, 3. So of course, that means I need my pot, which was given to us here. Then I need my SOT, which is just going to be f prime of 0, which if we go look at, we just found it, it was right here, -2. So f prime of 0 is -2. And then we write it. Y minus 3 equals the slope times x minus our x coordinate, but it's 0, so we can just write -2x. Amazing. All right, now this one takes a little bit more work here. We need to find f of -3. Now we already know f of 0. Why? Because they gave it to us at the beginning, right? We've been using it, 0, 3. They gave it to us here, f of 0 equals 3. So that means we need to integrate from -3 to 0 of fx dx. Because that'll be equal to f of 0 minus f of -3. And so then we can go ahead and solve for those. So here from -3 to 0, we're going to go from here over to here. Now, if we're smart about this, we can realize that these two are the same, and so we could just not include them and just instead find this piece here, which is a trapezoid again. So it's got a width of 1 and a height of 1 and 2. So we can go 1 times the average of -1 plus -2 over 2. right, had the wrong color there, so let's switch back. So -1 plus -2 is -3, so this will be -3/2. All right, and that's going to be equal to our f of 0 was 3 minus f of -3. So that's the one we're looking for, so let's go ahead and switch the sides of these two things. So +3/2 plus f of -3. And over here, we'll add 3/2 and add f of -3. Because, of course, that makes those ones cancel. And so we get that f of -3 is equal to 3 plus 3/2, which is 6/2, so 9/2 in total. All right, now we need to find the other one. So here we need to find 4. Now, we could use the one that we just found, -3. That makes it a lot bigger, a lot more unwieldy. Also, always better to use the stuff that was given to us. So better to use the integral from 0 to 4 of fx dx, which is going to be equal to f of 4 minus f of 0. And again, this one we can find, this one was given to us. So let's start by finding this from 0 to 4. Now, this one's a little harder because I'm going from here to here, which means I need to include these two awkward shapes. Now in class, you guys had correctly figured out, well, that could just be this rectangle minus the semicircle, and that's exactly what it is. So we're going to do this rectangle, which is a length of 4 and a height or width of -2. So this is going to be 4 times -2. And it's going to be equal to f of 4 minus f of 0, which was, of course, 3. Hang on, I forgot to subtract. Getting ahead of myself here. Forgot to subtract our semicircle. So sorry, that should be 4 times -2 minus, and then it's on the bottom, so it's actually going to be negative. So it's going to be minus negative or plus pi r squared, r is 2, squared over 2. I didn't go over that earlier, but if you look up here, we can see that very clearly our radius is 2, no matter where we're kind of looking here. Okay? And so that gives us -8 plus 4 divided by 2 is 2, so 2 pi. And that's going to be equal to our f of 4 minus 3. So let's add 3 to both sides. We get 2 pi minus 5 is equal to f of 4. And there we go. Excellent. And that's it, guys. That's going to be the end of that lesson. So we will see you guys next time.